So here we're asked to do prime factorization of 372, meaning write 372 as product of primes. And the prime factorization can be done in different ways, meaning when you start it, you can divide 372 by any number that you can notice divides 372 evenly. The easiest here is 2, for example. And then I would get 2 times 1 is 2, 16, 1, 186. You could do 2 again. And then you get 93. The 93 is divisible by 3 because the sum of the digits is 12, which is divisible by 3. So this would be 3 and 31. And 31 is prime. So if I had to write 372 as product of primes, it would be 2 times 2 times 3 times 31. Or you might also see 2 square, 3 to the 1, 31 to the 1. Now here I started by dividing by 2, but typically you want to look for as large a number as you can see. So I could start with, for example, 4. And the rule for 4 is if the number formed by the last 2 digits is divisible by 4, then the entire number is divisible by 4. So that would be 4 times 9 is 36, 1, so that gives me 93 just as before. And that's 2 square. So the divisibility rules help in doing the prime factorization. Part B of this problem asks to list all the positive divisors. And the process is a little bit different to find all the divisors of 372. You start with 1 and you divide 372, and then you go to the next larger number. And it's just trial and error. So you divide by 2. That gave us 186, if I remember. 2 times 1 is 2, 186. And then it is divisible by 3, 72, and then you divide it. So that's 3 times 2 is 6, 124. And it's also divisible by 4. 4 times 9 is 36, 93. And then it's not divisible by 5. It is divisible by 6. 6 times 6 is 36, 162, and then not divisible by 7, not divisible by 8. And in fact, if you look at the prime factorization, it was this. So that it's not divisible by 8 because I only have 2 2's. So I have up to 10. The next is none of the numbers are going to divide anything bigger than that. Actually, in fact, I notice it is going to be divisible by 12. And the way I observed is that 2 squared times 3 is 12. So a number that's written like 12 times 31 will be divisible by 12. So I divide this by 12, and the result would be 31 because we know 372 is 12 times 31. And that's it. After this, the next number is going to be 31, and we'll get 12. So it just repeats. So there is no other way to do this other than just listing them out in this fashion, and we just say these are all the positive divisors of 372, including 1, and we have 12 divisors.